Bula Vinaka. Well, that's the way we say hello in Fiji. Hello, children. How are you people doing? I'm Saurabh Kumar Dutt, and I'm here to teach you people a little bit of mathematics. Now, children, this scintillating place that you get to see is actually the Mama Nuka Islands in the volcanic archipelago of Fiji. It's an awesome place to be in, which offers you crystal clear waters, palm fringed beaches, and also live coral reefs. Make sure you visit this place, and all the people of Fiji that you get to meet there, do say to them Bula Vinaka. In this note, children, I'm going to start off this lecture of continuity, wherein today we are going to discuss about those examples of continuity where we get to see that the function has a left hand continuity or it has a right hand continuity. So let us quickly understand what left hand continuity and what right hand continuity is. Now, children, when we talk about continuity, then by definition we know this, that for continuity the left hand limit should be equal to the right hand limit should be equal to the value of the function at a point A at which probably you're trying to detect the continuity, right? So if say we talk about here a function where if the left hand limit is not equal to the right hand limit, then there's one thing that we know, that the function at that point does not exist. However, if we talk about the left hand limit to be equal to the value of the function at A but is not equal to the right hand limit, then it is known as left continuous, right? And further similarly, guys, if we talk about here the function to be such that the left hand limit is again not equal to the right hand limit, but if you talk about here the right hand limit to be equal to the value of the function, but we find that it is not equal to the left hand limit, then you will say that it is right continuous, right? So I'll just quickly discuss this all over because this is slightly ambiguous. Now here for continuity, you talk about the left hand limit to be equal to the right hand limit to be equal to the value of the function at a point A at which we are wanting to detect the continuity, right? But if suppose we talk about a function which is non-existent at a point, then obviously we will say that the left hand limit is not equal to the right hand limit. When such is the case, then one thing that is possible is that the left hand limit is equal to the value of the function at the point A, right? But it is not equal to the right hand limit. In that case, you call it to be left continuity, right? And further, if you talk about a function where you find that the right hand limit is not equal to the left hand limit, but the right hand limit is equal to the value of the function at the point A, then you say that the function is not continuous, does not exist at A, but is right continuous. Right, guys? So this is what we talk about the left continuity and the right continuity. Now we'll be talking about this in a little detail, writing the definitions. So when we talk about left continuity, then if suppose we are to write this by means of the mathematical definition that we've looked up, then you will say that limit x tends to A minus f of x will be equal to f of A, right? That is, the left hand limit is equal to the value of the function at A, and obviously further here in brackets we can write that this is not going to be equal to the right hand limit, which obviously can be written as limit x tends to A plus f of A is what it is not going to be equal to. As such, the limit at that point A is not going to be existent, as the left hand limit is not equal to the right hand limit. And except this, you also get to see that the function is also not going to be continuous, but it can be said to be left continuous when the left hand limit is equal to the value of the function at, say, a point A. Now guys, if we talk about the variable h, which is infinitesimally small, to be included, then we can write this definition further to be more precise, to be more exact, to be limit h tends to 0 minus f of a plus h, right, which is further equal to f of a, right, and obviously this is not going to be equal to the right hand limit, which we further do not require to write, right. So here, on introducing this infinitesimally small quantity h, we can better understand as to which function is applicable, right, in such a function where it has different values for different parts of the domain. Now children, let's talk about the right continuity. So when we talk about the right continuity, then guys, we will talk about the left hand limit to be not equal to the right hand limit, which further is going to be equal to the value of the function at the point a. Or in other words, we can say that if we have limit x tends to a plus f of x, that is going to be equal to f of a, right, and further this is not going to be equal to limit x tending to a minus f of x, and here, as we know it, we are going to keep it in bracket, right. So the main thing is this, that if we talk about the limit of a function at a point a slightly on the right of it, then the value of the function at this point is equal to the value of the function at the point a, right. So this shows us right continuity, which can better be written if we bring in the infinitesimally small quantity, that is h. So when h tends to 0 plus, if you talk about f of a plus h, then that should be equal to f of a, right. That is, if you talk about the right hand limit, it should be equal to the value of the function at a. So the function is not existent at a, right. It is not continuous at a, but it is right continuous at a if the right hand limit is equal to the value of the function at a, but is further not equal to the left hand limit, right. So these are what the definitions of these concepts are. You will better be able to understand this when we discuss sums. So guys, now we're going to discuss this out quickly, right, a recap of it, so that this ambiguous or this confusing concept be perfectly clear with you people, and after that we'll start off with sums. So here guys, in this question we've been given here that we are talking about continuity, right, and in this continuity we have this thing that there can be such sort of questions which can arise where the left hand limit is not equal to the right hand limit. So in accordance with what you learned till now, you will say that the function at this point a is not existent, but if you talk about either the left hand limit to be equal to the value of the function at a, which is not equal to the right hand limit, then you will call it to be left continuous. And similarly, if the left hand limit is not equal to the right hand limit, but the right hand limit is equal to the value of the function at a, so you will say that the function is right continuous, although neither is it continuous nor is it existent. Now for the children, we talk about the definition of this with respect to first a and then with respect to h, which is the infinitesimally small quantity for left continuity and for right continuity. So if we talk about limit x tends to a minus, right, f of x, then that's equal to f of a. So this is left continuity. Obviously in bracket here it's been written that here the left hand limit, right, will not be equal to the right hand limit, and as such this is not equal to the right hand limit, and this is what has been written. Further guys, we talk about this with respect to h, which is the infinitesimally small quantity, and here thus we can write that limit h tends to 0 minus f of a plus h is equal to f of a. That means here we are talking about the left hand limit to be equal to the value of the function at a, which is to be not equal to the right hand limit, right. Now for the children, if we talk about the right continuity, we'll be talking about the right hand limit to be equal to the value of the function at a, right, such that it is not equal to the left hand limit. This is something which is known when we are talking about right continuity, right. So if we talk about this with respect to the infinitesimally small quantity h, then we talk about limit h tends to 0 plus f of a plus h is equal to f of a, right? Or in other words, the right hand limit is equal to the value of the function at a. Obviously it is not going to be equal to the left hand limit. Now children, there's one thing that we can say, that is this, that if there is a function which is left continuous as well as right continuous, so directly we can say that the function is existent as well as it is also continuous, right? Now there is one thing more that you require to know, that is this, that whenever we talk about left continuity, there are three things which should happen. That is, the first thing is this, that the left hand limit should exist. The value of the function at the point at which you're detecting continuity should exist, and further the left hand limit should be equal to the value of the function at a. Similarly, when we talk about the right hand continuity, there are three things which should exist. That is, the right hand limit should exist, the value of the function at the point a at which you are detecting continuity should exist, and further the right hand limit should be equal to the value of the function at the point a at which you are detecting continuity. So is this all clear with you people? Arman? For sure? That's good, guys. We'll be discussing the next sum, that is this. Quickly give it a try, after which I'll be discussing the sum with you people. Like earlier, I'm going to give you 10 seconds. Tick-tock 1. Okay, time's up, guys. Now let's look up the sum. Now, don't take this sum to be pretty simple, as here this bracket that you talk about is actually the greatest integer function. So before we proceed with this question, I will quickly discuss what the greatest integer function is. So if suppose you have your function f of x to be greatest integer of x, remember it is an integer which is either the same number which in itself is an integer, or it comes to be an integer closest to the number which is given on the left hand side of the real number line. So let's now quickly look up the real number line. Let's say now that we have the real number line to be, say, looking something like this. And now on the real number line, let's say we talk about a few points. Now for that matter, let us now talk about a point which is, say, 0, then we have 1, then we have 2, then we have 3, or 1, 2, 3, then we have -1, -2, -3. So let's say now, guys, we've got a number which is, say, 1.4, right? So obviously it will lie somewhere here. Now if we talk about the greatest integer of this number, then like I told you, the greatest integer of a number is going to be the integer which is closest to it and on the left hand side of it, right? So if you talk about the closest integer to 1.4 on the left hand side of it, then obviously that is going to become equal to 1, right? Similarly, guys, if we talk about the greatest integer of a number which, say, is some 0.7, right? So if we talk about the greatest integer of this, then we are going to reach the closest integer of this on the left hand side of it, and now the closest integer which is on the left hand side of it is 0. As such, the greatest integer of 0.7 is going to become equal to 0. Now let's quickly look up a case which is negative. So if suppose we talk about a number which is -2.3, right, and we talk about the greatest integer of this, then you will talk about an integer value for this greatest integer function which is closest to this number, that is -2.3, and on the left of it, right? Remember, children, if you talk about this -2.3, it must be coming somewhere here, right? And if you talk about the closest integer which is on the left hand side of it, obviously the answer which comes to you is -3, right? So this is slightly different from positive numbers. In the positive numbers, you rather take a number which is lesser right? And if you talk about a negative number, numerically the number is larger, but actually it is on the left hand side of the number on the real number line, right? So this is what the greatest integer is. Now guys, we'll come to the question. We've been given here that if f of x is equal to greatest integer of x minus 1 plus the absolute value of x minus 1, then what continuity does f of x have at x is equal to 1, right? So the first thing that guys we're going to talk about is we'll be talking about the definition of continuity. So we will say that for continuity we have now the left hand limit to be equal to the right hand limit, which further is to be equal to f of 1, because you've got to detect the continuity at x is equal to 1. Next now guys, after this what we do is we will now be talking about the left hand limit, and for the left hand limit we will talk about limit x tends to 1 minus f of x to be equal to limit x tends to 1 plus f of x, which is further equal to f of 1. Right now, as x is not close to 0, so we will bring in the infinitesimally small quantity that is h. So we have limit h tends to 0 minus f of 1 plus h is what we have, that is further equal to limit h tends to 0 plus f of 1 plus h, and further that is equal to f of 1 for continuity at 1. So next now guys, what we do is we talk about the function which we've been given at hand, that is greatest integer of x minus 1 plus absolute value of x minus 1. So now we come to the left hand limit. So we have limit h tends to 0 minus the function is greatest integer of x minus 1. Remember, x is 1 plus h, and from that you got to subtract 1, right? X minus 1. And further guys, from this you have to subtract, you've got to add the absolute value of x minus 1. X minus 1 is 1 plus h, from which 1 is subtracted. Now this guys is your left hand limit. Now similarly we'll be talking about the right hand limit, that is limit h tends to 0 plus you have greatest integer of 1 plus h minus 1. It will be written in the same way, although h here is infinitesimally small and positive. And to that you've got to add the absolute value of 1 plus h minus 1, right? And now guys, after this, if we talk about further the value of the function at 1, right? So that then is going to become equal to 1 we have here x minus 1, as x is 1, so we will have 1 minus 1 greatest integer, to which is going to be added 1 minus 1 absolute value function, right? And since in both of these cases you get 0, so obviously 0 plus 0 is going to be 0, that is 0, right? Now guys, if you talk about the left hand limit, you have limit h tends to 0 minus, right, plus 1 minus 1 is going to get cancelled, so you will just be left out with the greatest integer of h, to which is going to be added the modulus or the absolute value of h, as plus 1 minus 1 will get cancelled. And further guys, now for the right hand limit, we will now have limit h tends to 0 plus 1 minus 1 will get cancelled. Again you will get greatest integer of h, to which you're going to add now the absolute value of plus 1 minus 1 getting cancelled. You'll just be left out with h, right? And further guys, that is going to be 0, like we discussed just now, that 1 minus 1 is going to be 0, so greatest integer of 0 obviously is going to be 0, right? And here absolute value of 1 minus 1, that is 0, is also going to be 0. 0 plus 0 will be 0. As such, the value of this function f of x at 1 is going to be 0. Now after this guys, next what we do is we talk about the right hand limit, the left hand limit. When we talk about the left hand limit guys, then if you talk about this number h is less than 0, right? So here if we talk about this value of h to be less than 0, right, then if you talk about the real number line, then on the real number line you will talk about a point which is on the left hand side of it, right, and is a real number, right, as integer, right? So as such, it is going to be -1 that you're going to talk about. As such, the greatest integer of this is going to be -1, right? So the value here that you will have will be -1, to which is going to be added the greatest, the modulus of h, which is 0. So obviously modulus of h, which in itself is a negative number, right? To which if you add, to which if you multiply minus sign, it will become positive. But as h is infinitesimally small, so obviously this finally is going to become equal to 0. Now guys, after this we talk about the right hand limit. In the right hand limit, now we will talk about h. Remember, h here guys is a positive number, right? Or in other words, we can say that h is greater than 0. Now let's talk about tracing it on the real number line. Let's say now this is 0, this is 1. So if you talk about h is on the right hand side of 0, right? And thus if you talk about the greatest integer, it will be a number which will be an integer and which will be on the left hand side of this number, and that obviously is going to come to 0, right guys? So next, now when we talk about the greatest integer of h, it is going to come to 0, as h is tending to 0 positive, and to that further you're going to add here 0 again, because the modulus of a positive number will be positive, that is, it is going to remain to be h, and as h is infinitesimally small, so it will become equal to 0. And if you talk about the value of the function at this point, which is 1, right, we found it is 0, right? Now guys, if you talk about the left hand limit, it is coming to -1, and further if you talk about the right hand limit, it is coming to 0, and if you talk about the value of the function at 0, it is coming to 0. Or in other words, we can further say that the left hand limit is not equal to the right hand limit, which further is equal to the value of the function at 1, right? So thus you can say that limit x tends to 1 f of x does not exist but is right continuous. Right? Now guys, after this, I'll just quickly discuss this all over. In the question you've been given here, that you have to check what type of continuity does the function have at x is equal to 1. So what we do here is we talk about the function f of x to be greatest integer of x, as has been given to you in this question, right? And the other function is the modulus function or the absolute value function, which has just been discussed in the last sum. So whenever you talk about the greatest integer of a number, it is always that integer which is either less than or equal to the number which has been given to you on the left hand side of the number on the real number line. So if say we talk about a point which is 1.4 and we want to know the greatest integer of it, then the integral value which is closest to this number 1.4 on the left hand side of it is 1. As such, the greatest integer of 1.4 is going to be 1, right? Next children, if say we talk about a number which is 0.7 and we want the greatest integer of it, so it is going to be the greatest integer, it's going to be the integer which is closest to this number and on the left of it, so obviously it's going to be 0. Then further we talked about another point. Let's say we talk about this -2.3, and as you know that here this point -2.3 is a number which is between -2 and -3, right? And thus if you talk about an integral value which is closest to -2.3 and on the left hand side of it, it is going to be -3. So this is how we find out the greatest integer of a number. I have made you understand this with the help of examples. Now children, for this question also you will talk about the definition of continuity, that is left hand limit is equal to the right hand limit is equal to the value of the function at 1. Then you will also be talking about the continuity's definition with respect to the point that you are discussing, that is 1 minus for left hand limit, 1 plus for right hand limit, and that further should be equal to f of 1. Now guys, here as x is not close to 0, so we will bring in the infinitesimally small quantity, that is h, and thus we will talk about limit h tends to 0 minus f of 1 plus h to be equal to limit h tends to 0 plus f of 1 plus h, which should be equal to f of 1. Right? Further now guys, we call in the function that is greatest integer of x minus 1 plus modulus of x minus 1. So when we talk about the left hand limit here, in place of x we have to substitute 1 plus h, so plus 1 minus 1 will get cancelled and we will just be left out with greatest integer of h. Right? Now here remember children that h is tending to 0 minus, or in other words h is less than 0. Howsoever small it is, howsoever close to 0 it is on the left hand side of 0. On the real number line it has been represented. So if you talk about the greatest integer of this, it will be an integral value which will be closest to this point, and on the left hand side of it, so obviously the value of this is going to come to minus 1. And when we talk about the other part of this function, that is 1 plus h minus 1, plus 1 minus 1 will get cancelled, only you'll be left out with absolute value of h. Now h, remember, is a negative number, although it is very small. Multiplied with minus sign will become equal to minus h, but finally as h is tending to 0 minus, we'll keep its value to be 0. As such, the left hand limit will just come to minus 1. Now guys, after this we have to calculate the right hand limit. In the right hand limit we have now again plus 1 minus 1 getting cancelled from the greatest integer function and from the modulus or the absolute value function. So we are just left out with the greatest integer of h plus the absolute value of h. Now for the greatest integer of h, remember this value h is tending to 0 plus, or in other words is positive, so it must be between 0 and 1. So if you talk about the integer which is closest to it and on the left hand side of it is 0, as such the greatest integer of this h is going to be 0. And then if you talk about the modulus or the absolute value of h, right, it is a positive number, so it will remain to be as it is, that is h. But since finally we've got to substitute the value of h, so that is going to be 0, and 0 plus 0 will be 0. As such, we will have a 0 here, right? And when we calculate the value at 1, we will have 1 minus 1 greatest integer, that will be 0 greatest integer. Obviously that will be 0 because it is at 0, so there's no integer that you can talk about which is closest to it but its own self. And similarly, if you talk about 1 minus 1 absolute value, that's 0 absolute value. For 0 it will remain to be 0, and 0 plus 0 is 0. As such, you find that the left hand limit doesn't match with the right hand limit, but the right hand limit matches with the value of the function at 1. Therefore limit x tends to 1 doesn't exist because left hand limit is not equal to right hand limit. But as the right hand limit is equal to the value of the function at 1, you will say that it is right continuous. So this is all guys that is there in the sum, and also in this lecture. Are you all clear about left continuity and right continuity now? For sure, Arun? That's good guys. Now I expect you people to practice all of this, right? And make sure any sums which comes your way during any examination, you're able to crack it well, right? And only then I'll be content. Okay, so bye guys, have a nice time and do practice maths. Bye guys.